Hi class, in lesson 1.2 we will be determining factor pairs using arrays and area models, and we will be classifying numbers using Venn diagrams. Key terms to look for in lesson 1.2 are area model, set, and Venn diagram. Let's take a look at problem 1 on page 16, where we will be using arrays to plan displays. Speedy Builders specializes in creating shelves, desks, and cases for collectible items. Speedy Builders wants to make rectangular cases with individual sections to display model cars. They want to design different size cases to display various numbers of cars. Before they build the cases, designers draw arrays on grid paper to make sure mistakes are not made. Think about a case that holds exactly 12 model cars with one car in each slot. What I would like you to do with your group members to get started today is answer questions 1 and 2. For question number 1, the arrays that could be drawn, we would have one row with 12 columns and 12 rows with one column. We could have 2 rows with 6 columns, or 6 rows with 2 columns. 3 rows with 4 columns, or 4 rows with 3 columns. For number 2, the relationship between the arrays and the factor pairs of 12 is that they are both the same. You can draw rectangles on grid paper to learn more about factors. Think of factor pairs as the dimensions of any rectangle using an area model. An area model for multiplication is a pictorial way of representing multiplication. In the area model, the rectangle's length and width represent factors, while the rectangle's area represents the product. If you take a look at the crew member and the word bubble, it says, remember, to write distinct factors means to list each factor once. The same is true for distinct area models. List the values of the width and length of an area model one time. If we take a look at the bottom of page 16, we can see the example for an area model for one factor pair of 12 that is shown. In this example, they give you an area model of 6 units by 2 units for a total of 12 square units. Let's turn to page 17 and take a look at number 3. Draw all of the possible distinct area models for each number from 1 through 30. You may want to use tiles before you draw your models on the grid paper. Label all of the dimensions of your models. Now this is actually going to go all the way to page 22, so go ahead with your group members and draw all of the distinct area models for each number from 1 through 30. Here are the distinct models for numbers 1 through 5. Our example for 1 is a 1 by 1. For number 2, we actually have 2 of them. We have a 1 by 2 and a 2 by, For the number 2, we have a 1 by 2 distinct model. For the number 3, we have a 1 by 3 distinct model. For number 4, we actually have 2 distinct models. We have a 1 by 4 and a 2 by 2. And for the number 5, we have a 1 by 5. For the distinct models for 6 through 10, for number 6, we have 2 models, a 2 by 3 and a 1 by 6. For number 7, we just have 1 by 7. For number 8, we have 2 of them. We have a 2 by 4 and a 1 by 8. 9, we also have 2, a 3 by 3 and a 1 by 9. And for number 10, we have a 2 by 5 and a 1 by 10. The distinct models for 11 through 15. For number 11, we have a 1 by 11. For number 12, we're actually going to have 3 of them. We have a 1 by 12, a 2 by 6, and a 3 by 4. 13, we have 1 by 13. 14, we have 2 of them, 1 by 14 and a 2 by 7. And for 15, we also have 2 of them, 1 by 15 and 3 by 5. The distinct models for 16 through 20. For number 16, we're going to have 3 of them, 1 by 16, 2 by 8, and 4 by 4. Number 17, we're going to have 1 by 17. For 18, we're going to have 3, a 1 by 18, a 2 by 9, and a 3 by 6. 19, we're going to have 1 by 19. And for number 20, we're going to have 3, 1 by 20, 2 by 10, and 4 by 5. The distinct models for 21 through 25. For 21, we're going to have 2 of them, 3 by 7, 1 by 21. For 22, we are also going to have 2 of them, 2 by 11 and 1 by 22. 23, we only have 1 by 23. For 24, we're actually going to have 4 of them, 4 by 6, 3 by 8, 2 by 12, and 1 by 24. And for 25, we're going to have 2 of them, 5 by 5, and 1 by 25. The distinct models for 26 through 30. For 26, we're going to have 2 by 13, 1 by 26. For 27, we are also going to have 2, 3 by 9, and 1 by 27. For 28, we are going to have 3 of them, 2 by 14, 4 by 7, and 1 by 28. And for number 29, we are going to have 1 by 29. And finishing up with the number 30, we are going to have 4 distinct area models, a 1 by 30, 5 by 6, 2 by 15, and 3 by 10. Let's turn to page 24 and finish up with problem 1. I would like you to do letters A through D with your group members on page 24. For letter A, the numbers 1, 2, 3, 5, 7, 11, 13, 17, 19, 23, and 29 have only one distinct area model. These numbers have factors of only 1 and themselves. For letter B, the numbers 1, 4, 9, 16, and 25 each have perfect squares as one of their distinct area models. We know that perfect square numbers have a factor that is going to multiply by itself. For letter C, the dimensions of each distinct area model are the same as its factor pairs of the given number. And finally, for letter D, you should be choosing a case with dimensions of 1 and 12, 2 and 6, or 3 and 4 in order to hold 12 cars. We are going to skip problem 2, so let's move over to problem 3 on page 26 and talk about Venn diagrams. You have created models to show relationships between numbers. Sometimes when numbers are related in some way to each other, the numbers are called a set. A set is a collection of numbers, geometric figures, letters, or other objects that have some characteristic in common. Another model you can use to show relationships among numbers is a Venn diagram, named after British logician and philosopher John Venn. A Venn diagram is a picture that illustrates the relationships between 2 or more sets. Venn diagrams use circles to help you put numbers into common groups. The example shown represents the natural numbers between 1 and 20 and the relationship between those numbers that are factors of 12, factors of 20, or factors of neither 12 nor 20. The numbers that are factors of 12 are in the region labeled factors of 12. The numbers that are factors of 20 are in the region labeled factors of 20. The numbers that are factors of both 12 and 20 are in the center where the circle overlaps or intersects. Numbers that are factors of neither 12 nor 20 are going to be listed underneath the Venn diagram. Let's take a look at the bottom of page 27. Number 1 says complete the Venn diagram to show the factors of 15 and 18. Use the natural numbers between 1 and 20. So go ahead and complete the Venn diagram with your group members and answer letters A and B. Here is what your Venn diagram should look like to show the factors of 15 and 18. For letter A, the numbers in the overlapping region are common factors of 15 and 18, which you see right here, 1 and 3. And the numbers outside the circles are not factors of either 15 or 18, and you can see those labeled here. Let's turn to page 28 now and look at number 2. This time we are completing the Venn diagram to show the multiples of 4 and 6. Use the natural numbers between 1 and 30. Make sure we understand that we are looking at multiples now, not factors when completing this Venn diagram. After you complete the Venn diagram with your group members, go ahead and again answer letters A and B. Here is what your Venn diagram should look like to show the multiples of 4 and 6. Again, for letter A, the numbers in the overlapping region are common multiples of 4 and 6, 12 and 24 that you see here. And the numbers outside of the circle, again, are numbers that are not multiples of either 4 or 6. That is going to do it for lesson 1.2 on physical models of factors and multiples. Please let me know if you have any questions. Thanks.